Welcome, gamers. Welcome to a new episode of Writing GNOME Documentation and Code. Oh. It's a tick. What's up with the bra? It's a tick. And I also use it to test the levels of the microphone. I mean, I could do something like or do anything else that looks like what other Twitch and YouTube streamers do, but I find it oddly comforting. It's a way to test the fact that my microphone is actually working and the levels are not terrible. Plus, it's a marker when I do the VOD. I'm giving away all the streamer secrets here. When you're releasing a VOD and you are subdividing stuff into chapters on YouTube, then you need a marker to know when you start talking. And bruh, it's the marker that I use. But yeah, a little bit of streamer inside knowledge. So, I hope it's been a good day for everyone involved in the audience now. I also noticed that my followers count has jumped up by about 20 people. I have no idea how many of these are bots. Finally, my Twitch account has been discovered by spam bots. You never know. Oh. So, on Monday, I tried doing a couple of things in the developer documentation website to ease the maintenance up to a point. They didn't entirely succeed. Well, one of them like right out failed, and the other one instead succeeded halfway. But today I actually wanted to go back to the getting started tutorial for writing new applications, new GNOME applications, and basically just start writing a small GNOME application as a way to guide people into writing their own application. Ideally, I would love to take the result of the VOD, edit it down into a reasonable size, and then publish it. Because I've been asked by multiple people on social media and comments on YouTube and elsewhere if I could work on a video on basically explaining how to start a GNOME application from scratch. I guess it's the most complicated thing up to a point. People don't know where to start, how to start. Oh, I'm sorry. That was very rude. I didn't expect that to be so strong. But yeah, so the plan today is to literally start Builder. and then create a new project, fill out a couple of details, and then start writing an application. So the application I have in mind is not a complex one. It's going to be a very simple text viewer, which is similar to the example application that the GTK API reference has in its own getting started documentation. But unlike the GTK one, I will use libadwaita, and I will just package it up using Flatpak and everything else that GNOME applications can depend on because are part of our platform. Whereas GTK applications are supposed to be less beholden to the overall GNOME platform. It's going to be a simple text viewer because I don't want the complication to completely overload the goal of the project, which is a simple getting started tutorial. But it contains enough complexity to demonstrate what you can do with Builder, what you can do with the GNOME software development platform. Nothing complex, just handling text buffers. Yes and no. I mean, I'm not going to go deep into the rabbit hole of here's how you do syntax highlighting, and here's how you deal with multiple buffers and multiple text views and everything else like that. Mostly, I'm meaning to give you the ability to open a text file and display its contents, regardless of what the text file is or it contains. The other thing is that it allows me to then be able to take this and link to the proper pages in the UI components list of tutorials, even the ones that I haven't written yet. But yeah, so this is the plan. The plan is a very simple text viewer that lets you open a file, display its content, and then we can figure out things like saving states or doing things like like settings for an application, displaying side information like the current line of the cursor and the current column of the cursor, and simple things like that. I'm not gonna go into tabbed UIs or things like that because they are, again, a little bit more complicated. I don't want to start developing a simple text editor. That's kind of pointless. Though to be fair, there is another option for another getting started API, which is a simple image viewer. The main problem with simple image viewers is that image viewers are not simple at all. Unless you want to visualize a very small like image macro, so 500 pixels by 500 pixels typically. If you want to go into the nitty-gritty of loading photos or large images, then you have to end up using specialized libraries like Gaggle. And once you start getting into Gaggle, then you have to write your own GTK widgets that load the Gaggle buffers and things like that. And also opens the possibility of doing editing of images and transforming image formats. So you load up JPEG and you save it as something else, or load up ping file and you save it as, I don't know, whatever. So I don't want to make this too complicated. I don't want to make writing the code too overwhelming for a newcomer. But one of the things that we had on the old development documentation website was a set of demos of different tools. And one of them was an image viewer, and another one was a guitar tuner or something like that. So ideally, the new developer documentation website could have a section on specific demos. A more complex text editor with multiple tabs, for instance, and printing support even. And an image viewer that allows you to do simple manipulation, and so on and so forth. Those are usually employed by other platforms as ways to guide you into very specific tasks. So how do I load an image with this platform? How do I display it? How do I do complex UIs based on that? But we are not there yet. We are not there yet, so there is no point in me trying to make it more complicated than it actually needs to be. So let's see, and let's go to my desktop so we can start. So we will, instead of using an open project, we will start a new one. And the new project will have a name that is going to make it slightly obvious. So we're going to name it text viewer. The application ID is going to be example text viewer. And we're going to use C for the time being. Ideally, I want the ability to take this example, write it in C, then write it in Python, and then write it in JavaScript and other languages, so we can demonstrate the flexibility of the platform. There are two problems with that. The first one is that currently on my version of GNOME Builder, which is not the bleeding edge one, the only languages that allow you to do GTK4 and recent GNOME are C and Python. They only have those templates. The other problem is that, again, in my version of Builder, which is not the very latest, the template for GNOME applications using GTK4 does not include libadwaita. That happens because it's not part of the GNOME runtime, released GNOME runtime. The only GNOME runtime that currently ships with libadwaita is the nightly snapshot. So what will become GNOME 42 in March. So right away, we will have to tweak a couple of things inside the generated code base that we will have. But in the future, the documentation will simply let you select a language, and then we will have multiple tabs with different implementations. And I'll try to write the text in the most language neutral way I can, so I will not have to do a lot of translations between languages. But this corresponds with the modules JSON for @waita on top of 41. Yes, there is indeed. I think I saw it pass. I get all the all the discourse topics, because I'm one of the admins. So if something gets posted on discourse, I usually see it. But yeah, it's possible to use libadwaita on top of GNOME 41. Ish. Well, you have to also build GTK4 because GNOME 41 ships with GTK 4.4 and libadwaita requires GTK 4.5 at the minimum, which is the development version. But yeah, in theory you can do it. In theory you can just start from the GNOME 41 runtime and then build on top of it. For this particular example, we are going to go with a GNOME application, and then we will modify the flatpak manifest to use GNOME Nightly, the latest version of the GNOME SDK. So we won't have to deal with that. I'll also have to modify a couple of things. So again, the idea of the next version of GNOME Builder, so GNOME Builder 42, is to have a different template that includes libadwaita as well. So as soon as you hit create project, and after selecting the GNOME application template, you will get a template that works with GNOME 42, libadwaita, and includes even libadwaita API inside it. On our side, in this case, we will have to do this manually. Oh, hi, Dukids. Welcome. So, as I was saying, text view, application ID, it's text viewer, language C, license GPL v3+, and selected a GNOME application template. And then we tell it to create the project. So we have a project. We have a basic project. The first thing we do is go inside the flatpak manifest, and instead of using 41, as we were saying, we are going to use the master runtime version. We download the runtime. So we download all the dependencies. We already have them. And then we select everything. So you can see we're using the master platform, master runtime. And yes. Okay. So let's see if we can build it. The build succeeded, and we can run it. And we have the very basic hello world example. So everything seems to be working fine. Now we're going back. We're going to go back. So as I was saying, this example has the template only uses GTK, not libadwaita. So in order to use libadwaita, we have to go into the source code and into the application code. And instead of using a GTK application, we are going to use libadwaita application. Everything else works exactly the same because it's precisely the same. Adwaita application is the base application class for libadwaita, and all it does is initializing libadwaita types and all the internal state of the library. For everything else, it is exactly like GTK application. So it can use GTK application window, you can use the GTK application API, and so on and so forth. So now that we have this, modified that particular bit, we have to go inside the application header so it doesn't inherit from that. And instead of including GTK, we include widget. Sorry. I think. No. Whoa. This is not good. Oh yeah, of course. We have to modify the build system to depend on widget. Otherwise, nothing will ever work. It's a different of course, now we have to find I bet it's called libadwaita. Yep. No, it's package API name. And of course, we'll have to find where that is defined, because where are you? Where are you defined? There it is. Yeah, it's called libadwaita 1. Yes, I could have grabbed other applications. And now it works, of course. Oh, now you can see there is a difference. The style is different, you might have noticed. The style of the close button is different, and the window has rounded corners everywhere. So now we're using libadwaita. So this is how libadwaita application looks like. And there we go. So we had to do a simple modification there. Not a complicated one, but we had to modify the build system to find libadwaita, and that's it. Okay, so now that we have a libadwaita application running, we can go into the UI definition file and start looking at how the UI is structured. First of all, we have a header bar here with a menu button that contains the primary menu. And the primary menu is defined like this. It has a preferences, item, keyboard shortcuts, and an about action. So if we run it, You can see here, preferences, keyboard shortcuts, and about text viewer. Preferences isn't connected to anything because we don't have a preferences dialog. Oh, hello, Alosarius, and welcome. But the keyboard shortcuts is already populated with the existing shortcuts that are defined by template, and the about dialog is also available here. So as you can see, it's a fairly simple skeleton of a GNOME application. And this is the main application window. So let's see. First of all, we probably don't want the title of the application to be just text viewer. So let's start with a basic title. Basic property definition, and we call that text. Yes. And that's it. We will have to modify this when we load the file or our simple text viewer, but that's a start. Okay. So a text viewer is going to be made by an area of the window that display text. We cannot use a GTK label, of course. A GTK label is a simple text widget that is used for very short fragments of text, one line, a few lines at most, and they're usually either hard-coded, so all your labels for your UI, or they are generated by the application programmatically. So it's definitely not used to display the contents of a file. So we remove it. And instead, what we want is a text view. Now, we cannot just shove a text view inside here. And we cannot do that because, let me close a couple of these. Right. We cannot do that because if we do that, the contents of the text view will continue to grow once we load a file. And will continue to grow, making the window grow. So let's show how that happens. Let's see here. We don't need to specify again. Focus. For the time being, we just add a text view here. So build it. But you can see that, oh, I cannot retrieve a child name label from the UI definition file. Why that happened? Because we have an object here, and we gave it the identifier main text view. That main identifier is bound to the text view class using what we usually call a template. So in the template, we have to specify the widgets that we want to have access to all the time, every time, whenever we create an instance of the object. So we use this function called GTK widget class bind template child, and we specify that the field that will contain the template child is the main text view field inside the text view window structure, instance structure. The template is defined inside this resource, and resources are compiled into the final binary that will be the application itself. So a template is just a way to take a GObject class here and then have it mapped to a UI definition file here. And everything that we want to access will have an ID, which will then be taken and assigned to a field inside the instance structure. And we typically will use a resource defined inside the gResources file here, because then the build system will take the files, like the text viewer window UI definition file, and will compile it directly into the final binary, and will load it up once we launch the library, once we load the application. The end result is that you don't have to install a bunch of ancillary files like UI definition files or everything inside the file system at the end of the process, at the end of the installation phase. But it will be compiled into the binary, compiled into the binary in C. In other languages like Python and JavaScript, they will be compiled into a binary blob that is very efficient because it will be mapped directly into memory and then will be parsed once, and it will be done and discarded. So it's going to be very efficient. So now that we modified the class, you can see that we have, instead of having a label that says hello world, we have a text view. Libadwaita now is available with C, Rust, Python, JS, and Kotlin bindings, I think. Libadwaita generates introspection data, so it's available to every language that has introspection-based bindings for any GObject-based library. So definitely Rust, Python, JavaScript. It's also available in Perl. I don't know if Kotlin doesn't use, the Kotlin bindings, as far as I know, do not use introspection. They are handwritten, which means they will have to be updated. There are C# bindings, I know, in progress. There are Guile and Scheme bindings that are currently in progress. So everything that can load introspection data automatically has access to libadwaita. So there can be a lot. There can be a lot. Oh yeah, C++. Yeah, C++ is another language binding that does not use introspection. It's not manual. They have their own introspection format, which actually predates every other format. They have a parser of the C header files that will generate, if I remember correctly, S expressions that will then be turned into C++ headers. Okay, so we have a text view, but if we notice what happens when we get to the end of the line, you can see that now the window grows. Oh, what happens now? Hi, Chipwill. I can't decide which language to use for GTK app devel. My strong suggestion is to choose whatever language you feel more confident and comfortable with. Most of the languages, mainstream languages, have access to introspection-based bindings. If you feel comfortable with Python or JavaScript, go for it. If you like compiled languages, Rust and C are perfectly fine. My overall suggestion is literally, do not try to learn a language while trying to learn GTK. That's a double whammy. That's usually very complicated to do. So it's an added complication because GTK is its own set of concepts, its own set of practices. So if you try to learn GTK while at the same time learning another language that doesn't explicitly map, it's going to be a problem, because you might end up into non-idiomatic usage of the language, or you might end up in non-idiomatic usage of GTK. So if you already know a language and there is a binding for it, but there's a binding for GTK, go for it. It's going to be a lot easier to deal with. If you're using GTK as an excuse to learn a new language, it's also a possibility. Just be mindful that you will have to deal with possibly non-entirely idiomatic construct. So you might learn the language wrong. Or, well, less likely you will get GTK wrong, but it can be an additional burden. So just be careful about that. Okay, we are growing the GTK text view whenever we add new lines. So we end up with a larger application. And that is not great. That is not great at all. Imagine if you loaded like a massive file. What happens then? It would be great if we could make the text view scroll. How do we do that? Well, we add the text view inside a scroll window, which is a GTK widget that has nothing to do with Windows. But has to do with being able to scroll other widgets inside it. So let's go into the documentation for GTK scroll window. Here. GTK scroll window is a container that makes its child scrollable. Okay. No, I went. So yeah, a lot of people end up confused by the name scrolled window. Sadly, is historical baggage. It's a little bit of an implementation detail from the GTK 1 era that we kind of are stringing along. We'll probably be able to fix it for GTK 5. And call it GTK scrolling area, maybe, or something like that. Yeah, a GTK scroll window has a child property, which defines the child widget. So that's what we are going to do. We define a GTK scroll window, we take the child property, and we add the GTK text view inside that. Of course, this gives us a little bit more now you see that we can actually scroll. And we have a scroll bar automatically here, and everything else that comes with scrollable widgets. We also have the little indicator at the top, the rubber band indicator that tells us we are at the top. You cannot scroll any further. And at the bottom as well. Well, at the bottom, you can barely see, but yeah, it's there. A little bit of a gradient. I don't know if it gets captured correctly. Yeah. Also, the scroll bar can be grabbed and moved, and you can see it grows in size when you cross it. And it changes in color, so it tells you that you can grab it. It's grabbed. And another thing you can do, it disappears as soon as the area is big enough, and it's scaled with the rest of the and yeah, and also GTK will handle the middle button. So if you press the middle button, it will page. Otherwise, if you press the primary button, which is usually the left one, it will just jump to the right position. So all of this is handled by GTK itself. It's pretty cool. It's pretty easy. But it's not entirely enough. So the window that we see here has a default width and default height properties, and they will determine how big the window will be at the very beginning. So if we do something like this, and we rebuild it, we start it, you can see that it hasn't changed really, which is why it hasn't changed. Well, because a window is also driven by the size of its children. So it's not just a default size. It will also have the it will also be its default size will also be the result of how big its children are. And a scroll window and a text view inside the scroll window will have a size of 1. It can be scrolled down to nothing. It can be resized down to nothing. So what we really want is to have content height that is the minimum size to be useful. So if you size it like this and then you resize it down, I mean, this is kind of useless. You probably want to have it a little bit bigger. But yeah, you can do it by specifying the minimum size in pixels. For instance, let's say 500 pixels. Run it, and suddenly the window is bigger because we told it that we want 500 pixels minimum size, and we cannot resize it any, we cannot make it any smaller. So this is going to be the size of the window vertically. And there is also a minimum content width, so we cannot resize it horizontally, meaning less than that. But we don't care about that for the time being. That's just an example of what you can do with the scroll window. You're not strictly limited to the size of what's inside. You can also give it a minimum size and also a maximum size. But that is not entirely useful for the text view case. So the real thing that we want to do is to ensure that the scroll window is actually always expanded. So I'm going to explain what this means in just a second. So widgets are, well, widgets have an implicit size. So they have internal size. They can be defined to be to have a minimum size and a natural or the default size, or the size that is the using natural again, the size with which the widget is at its most useful. So it's the size that will be preferred whenever the widget will be asked, how big are you? And how that works is that the parent of the widget will ask to the child, how big must you be? So the minimum size. And how big do you want to be? Those are the two sizes that every widget has. Then at some point, the parent of the widget will give the widget a size, because it will come from its own parent and so on and so forth until we reach the top level window. So each widget will be given a size that is going to be between the minimum size that the widget must have to be useful and the actual size that is the preferred one, the natural size. But widgets can also be bigger than the natural size. So the minimum size provides one boundary, but the other edge of the allowed area is entirely up to the parent to decide. And we can tell a parent that the child widget can expand, so it can have a size that is it can be given a size that is bigger than the natural size or the preferred size of the widget. And that is done using the hexpand and vexpand properties of GTK widget. Hexpand means horizontally expand, and vexpand means vertically expand. So in this case, we are telling the scroll window, if you've been given more room to grow during the allocation phase, so during when the parent gives you more room, take all the room you get. You don't need to be limited to a specific size. And this is usually employed to structure your UI so that you have bits of the UI that can grow and bits that can shrink and bits that have to stay at a certain size. One of the fundamental things that GTK does is not to fix the size of each child and each widget using pixel sizes. GTK will force you to structure your UI in terms of being able to expand, being able to grow, being able to shrink, ratios between widgets, but also if you have, for instance, a text UI element like a label, you can tell it, please display n characters or by default, or at most x characters before doing things like wrapping text. This has two fundamental use cases. The first one is it makes your UI more fluid and more responsive in terms of sizing. So taking your window and resizing it will not make UI completely break. And the other advantage is if the user changes the font size, or the user is using a different locale, so a different language than the one you wrote the application in. So for instance, I write applications in English, but they can be translated into, I don't know, German, French, Italian, Russian, whatever. Once you do that, the size of the labels, for instance, will change, and that will result in the UI changing as well. And if you set everything in pixels, you will break the UI if you translate something. If you translate from English to, I don't know, German, usually the labels will be longer. It's a fact of life. At that point, if I set all the sizes of all the UI elements, like all my buttons, in pixels, and I used English as the baseline, then as soon as I translate into German, either my labels will be ellipsized, so I will not see the entirety of the word, or the UI will break because the text label will be bigger than the allocated space. So fundamental thing in GTK is definitely not to use pixel sizes, except for defining things like the default size of the window. So, okie dokes. We probably don't want to have the content of the text area to be so flush with the edge of the window, because it's really too close. It's hard to read. So we probably need to use some margin. Hi, Rednoff, and welcome. How do we do that? Well, we could use some CSS, but I'm not going to go into styling right now because that is a little bit too complicated. But we can start with simple properties here, like margin start, and we give 4 pixels. And 4 pixels on the left. So the margin properties are for margin top, margin start, margin end, and margin bottom. They are called margin start and margin end instead of margin right and margin left, because if you're running your application under a language that is right to left, for instance, instead of being left to right, like English, if it's right to left, all the UI will flip. Let's see if I can give you an example using the inspector. Okay. There we go. Yes. So this is the inspector, another very useful tool in the development of GTK and GNOME applications. The inspector, if you've never seen it, works exactly like the inspector inside web browsers. So you have the list of objects that are currently inside your application, each property for every object. You can select a widget and gather all its properties and its current state. It's the styling state. What kind of actions are bound to the to each widget. Event controllers, the accessibility information. But yeah, as you can see, the direction currently is left to right, because I'm running with an English locale. So if I go to global and settings and select text direction, right to left, now you can see that everything is moved to the left, because the text direction is now the opposite. So this is a very useful way to check that your UI is currently working when using a non-English, but non-left-right locale. Again, GTK does this for you all the time, so you don't have to strictly care if you're using GTK widgets and libadwaita widgets. If you're writing custom widgets that lay out their children in specific ways, so if you write an entirely custom widget, then you probably will have to care about this. And this is a good way to test. Additionally, if you're running with Adwaita, then you have an extra panel here that allows you to check the behavior when running with different color schemes. For instance, I prefer the dark one. There you go. I prefer the light one. There we go. And I prefer the high contrast one. And here we are. So all of this is included automatically inside the inspector by libadwaita. If you're using this, if you're using the inspector with a plain GTK application without libadwaita, you will not have this additional tab here. Yeah. And now you can see we have a little bit of room here on the left, and you will see it on the right if we had a line long enough. And that's it. There you go. So our text is not so flush with the edge of the window. Though we might probably want to maybe have some room there or at the top. So we can modify that as well. So the vertical margins do not have a leading and trailing version because they will not change with the text direction. And let's see. There we go. Now we have a little bit more room. Okay, so this is just messing a little bit around with the appearances of this application. What we want to do now is to also have a way to open a file, which means selecting a file inside the file system, and then loading its contents, and then displaying them inside text view. So in order to do that, we first need to add a way to load a file. And to do that, we follow the user interface guidelines from GNOME. So we want to go in the, let's just go on developer gig. We go to the human interface guidelines for GNOME. And then we look at containers, header bars, and we look at the button style for the header bar. We usually do multiples of 6 for margins. Yes, that is true. That is true. So let's go back and modify that. But yeah, as you can see, we have a way to add a new file to the header bar. So the idea is to add a button to the header bar that lets you select a file. We have two options. Either we have an open, a button labeled open with a down arrow that opens a menu with a list of recently open files, like say text editor here. Or we add a new tab here and then we open a file here. As I said, I don't want to add new tabs. I don't want to add tabs to this UI because I don't want it to be too complicated for getting started application example. So we're just going to add a button, a single button that says open. And to do that, we add a GTK button child to the header bar. Since we want it to be on the opposite side of the close button and the primary menu, then we tell it to use child type start. This is a feature of the GTK header bar widget. So if we go here, and we go to the GTK header bar page, you will see that it has a section called GTK header bar as GTK buildable. Every time a GTK widget has custom ways to be described inside a UI definition file, it will have this section, like GTK blah as GTK buildable. And it will include what kind of exceptions or what kind of elements, what kind of additional elements and attributes the widget will use when described in XML. In this case, we want to take advantage of the fact that it supports adding children at the start or end sides by specifying start or end as the type attribute of an element. So the primary menu in the header bar, which is the GTK menu button, is packed at the end of the header bar, and the open button is packed at the start. GTK header bar is a container, yes. So if you're used to GTK 3, GTK 4 is a little bit different. GTK 3 has an explicit GTK container API that widgets that have children widgets must implement. So every time you want to create a new class that can have a new widget class that can have children, you must inherit from GTK container. GTK 4 dropped the GTK container API. The type doesn't exist anymore because every widget can have children, and the API to traverse the children and to add a child and remove a child has been moved into GTK widget itself. This means that a lot of widgets will be able to add children inside GTK 4 without necessarily having that as specified as part of the type hierarchy. But you basically just need to look at the API reference and it will tell you if it has children or not, or if it has API to pack children inside a widget. For instance, GTK header bar has two APIs, pack start and pack end, and then remove to remove stuff, also set the title widget, and so on and so forth. Other widgets might have a single child, so you will have an API that's called setChild and getChild, and a single property that is called child, for instance. Other widgets like GTK box have a more complex API that lets you append, prepend, remove widgets. So again, it's part of the API reference. We might end up adding like an explicit document that says these are the container widgets that GTK provides out of the box. Right now we don't have it because it has to be written manually. But we also have a widget gallery that you can check, so you can immediately see what is what. Buttons here, entries, and then we have a list set of containers like boxes, grids, center box, the scrolled window, the panes, the frame, an expander, the search bar, and so on and so forth. So you can see all of these are containers. So we added a button. Let's build it and run it. And we have a button here. It doesn't do anything right now because we merely asked GTK to add the button, but it's there. So how to make it do anything? Well, for starter, we have to go into the code. We call the open button. So we add a button here. And then we have to tell it to do something when running. So as part of the template, inside the instance initialization function, which is this one for our window, we have to call GTK widget init template. This one will be done for you by the project template that GTK Builder has. But if you write any other widget type in GTK4 or libadwaita, you will have to initialize the template. This one, what this function does is it parses the contents of the template and then finds all the children that you have defined here. And then it will bind them to the field inside the instance structure. So once you've called this, open button will be defined inside the instance structure, which is good because then we can do something like so now we're going into GTK esoterica. We want to have this function here called every time the user clicks on the open button. So we have to go into what are signals and what are callbacks. So every G-object can define signals, which are not at all like Unix signals if you're familiar with command line development. Signals in G-object are just fancy ways of saying, here's a list of functions that are bound to a name, and I want you to call them all in sequence when I use that name. So we defined a clicked name, and then we bind the text viewer window open clicked function to that name. So the button will, at some point internally, emit the clicked signal, and the click signal will, and the signal machinery will go through all the functions that have been connected to that name and will call them in sequence. And the clicked signal in GTK button, let's quickly go and see what it is. It's defined like this. It's in this case in C, is a static void clicked function that takes the button as the first argument and takes a user data pointer as the second and last. This signal is, as the description says, emitted when the button has been activated. So when you press and release the pointer, or when you press return and click the button using your keyboard. So now we need to define that function. Let's copy this because it's easier. But we gave it this name, not just clicked. So we also want to make it static to this, so we don't have to deal with that. And there you go. Now we are passing the window as the user data here, which means that we can do text viewer window self equals user data, and just as a test run, we can use something like this. Open, click, and we can run it. Oh yeah, it's not self here. Button. Let's redo it. And we have here, we press open, and we get here that we click the button. There we go. So now we have our button that can be clicked. What are we going to do with it? Well, first started, we want to select a file. So at this point, we need to be able to open a file selection dialog. And the file selection dialog that we're going to use is the file choose native dialog. So GTK has two file selection dialogs. One is file chooser dialog here, which is the file selection dialog that we all love and hate, and love to hate, and hate to love. This dialog runs in process, which means that it works fine for every application that is not sandboxed. But if you have if you want to distribute your application using Flatpak, for instance, or in general, or Snap or any other sandbox systems, then you have to use GTK file chooser native. And the main difference between file chooser dialog and file chooser native is that the file chooser native is not a GTK dialog, so it's not an actual widget, and that is one. And the other one is that it doesn't run inside your own process, it runs out of process in general. Another useful case for native file chooser dialog is that when running under, for instance, Windows, or running under macOS, or running sandboxed under another environment that is not GNOME, they will be able to use the native file selection dialog for that platform. So if you're running on Windows, it will pop up the Windows file selection dialog. If you're running on macOS, it will run the macOS file selection dialog. And if you're running your application inside Flatpak on KDE, it will open up the KDE file selection dialog instead of the GTK one. So it will be integrated with the system that you're running your application on. Of course, that comes with side effects. Now you have a sandbox application, which means you cannot just do whatever you want, but you have to select a file and you have access only to that file, for instance. In our case, we don't care because we are only going to select that file. So we have an example here for typical usage, pretty trivial. So we can actually copy what we want. And then we are going to move the handler here out. And that. Then we have this function here. Okay. So and there you go. Okay, so we have our file chooser native dialog that is going to be created. It needs a parent window. A parent window allows us to bind the dialog to the application window on the window manager side, but also on the toolkit side. In this case is necessary because then since we're running the file selection dialog out of process, or at the very least we are running it not tied to the actual we might be able to run it out of process and tied to the window across different processes. So we actually need to specify the parent window. The parent window is just our text viewer window. So we're gonna call it this way. Since we inherit from GTK application window, which is a GTK window, we can just use this. The action we are using, we don't need to have a separate variable to do that. One file chooser action open, because we want to open a file. And we want two buttons, one is open and one is cancel. The way we do this is to use a mnemonic here. So a mnemonic is a GTK term. I honestly don't know how other platforms, the name other platforms use for this function, but it's the little underscore under a letter in a button label, for instance, or a menu or whatever that allows you to select that action using your keyboard or using the Alt modifier. So in this case, we want GTK to allow you to select open by using Alt-O and cancel by using Alt-C. And GTK does it by basically telling it to use this underscore here. And then what we do is we connect the native dialog that we created. Whenever it emits a response signal, the response signal is emitted whenever you press open or cancel, or you close the dialog, basically. And when that happens, we want it to call the onResponse callback. And we want to pass the top level window again as user data, so we can use it later on. And then we want to show the dialog. Once the dialog is shown, it's going to be modal. So it's going to wait for input until it gets a response. The application underneath will continue to run, so if there are some timeouts or anything that are running, they'll still run. But as soon as you close it, because you selected a file, for instance, it will emit the response signal. And in this case, we want it to be this. So if the user has selected a file and pressed open on the dialog, then we want to get the file that has been selected, and in this case, open it. So instead of using this, to avoid all of this, we can use pointer. This one is mostly useful if you're using GCC or CLang, which is a nice shortcut for writing applications on Linux. So what we are doing is we're using the GTK file chooser interface, which is the interface implemented by all the objects that allow you to select a file for opening or saving. It's implemented by GTK file chooser native, as you can see here. And then we want to get the file that has been selected. So we use GTK file chooser get file. Get file returns us a G file object. A G file is a representation of a file, either on local file system or a remote file system, it doesn't matter. It's a representation of a file. So you can go here and see. And you can see we have a bunch of constructors for that, but also we want to look at, for instance, the path that we actually open. So we want to print out the path. So it should be a peak path. Yep, here we go. So right now we don't have code for opening the file, so we comment it out. But we want to know what kind of file has been selected. So we print it out. Print. There we go. And there we go. So this is the first step. We have an unused variable here. We can move it. So one less warning. Then we have a bunch of unused API. So there we go. And here, for the time being, we don't use it. I don't particularly like warnings, so okay. As you can see, press open, pop up the selection dialog. And we want to select my to-do. We open it. Of course, nothing happened because we don't have a way to load the file right now. But we have here what kind of file we selected. Since we're running a native file chooser dialog and we're using Sandbox to do that, we get a link to a specific location on disk that is handled by the portal, the document portal, the document portal, which means that our application currently only has access to this file and nothing else. The file selection dialog allows me to view the entire file system because it's running outside of Sandbox. But once I select a file, the application will only see the file that I selected and nothing else. So security, yay for us. Now we want to open the file, which means taking all its content and then putting it into the text view. So the text area widget that we have. How do we do that? Well, for starters, let's call open file, and we pass the viewer window and the file here. We will need the window because the window has access to all the widgets that it contains. So since we want to add the content of the file inside the text window, text view window, then we need to pass the window itself. And then we pass the G file. So since G file is a representation of the path, then we can, and not only it allows us to see the path, see the file that we have, but also allows us to get its contents, for instance, like this. We use G file load contents async. Why are we using an asynchronous version? Well, right now we are running inside the GTK main loop, and it's all done synchronously, which means that if we open a file here and we slurp all the contents of the file, then we are blocking until that operation has been completed, which is probably fine for a small file like the to-do list that you've seen, because it's a very small file. It's less than a page of kernel memory, so it means that the kernel is probably going to load it essentially instantaneously, and the buffer is going to be slow. It's going to be small enough that we can load it in one go. But we might want to load any arbitrarily sized file from the file system, and the file right now I'm running on an SSD, but I might be running over a network storage, or I might be loading a file from a cloud service, and that can be very slow, which means that we are blocking the UI loop while we are loading the file from Alpha Centauri. And since that will take years, then we are going to block the UI for the entire duration of the operation. Luckily for us, G file comes with a large variety of asynchronous API, which will perform the operation that we tell it to, in this case, loading the content of the file, in a separate thread, and then we'll re-enter the main loop when the operation is complete. But we are not going to block the main loop while we do that operation. So, how does it work? Well, it's pretty simple here. Content async, so we pass the file. Then it wants a cancelable, which we don't have, because we don't want to we don't have a way to cancel the operation. The cancelable is an object that allows you to say, I'm not interested in this anymore, please cancel the application. It's useful for both synchronous and asynchronous API calls, but in this case we don't have any way to perform that operation, so we can pass null there. And then we want the gfile load contents async function wants a callback and user data. Callback is very simple function, so on open file complete. And then we want to pass the text viewer window top level. And basically that's it. This is our open file function. Please load the contents of this file asynchronously for me, and when it's done or on error, please call this function. It's a gsync ready callback, which has this signature. So let's copy it. And we call it open file complete. This function takes the source object as the first argument, the result of the asynchronous operation, and the user data. The source object is the object that started this operation, so it's going to be the G file in this case. And the async result object is the result of the operation. Inside this callback, what we have to do is tell the G file that we finished the operation. So G file contents finish. Okay, so the result, the contents, the length, and e tag out, we don't care, and an error. So what are we doing here? Well, we tell it, the G file, that we finished, we want to complete the operation. So we tell it to take the asynchronous result, and from that, either give us the contents of the file that we just loaded. And since we are talking about contents of a file, they can be any in any binary format. So we need to pass the length of those contents. Because we are really what we are really getting is not a string. We are getting an array of bytes. And now that we're getting an array of bytes, we need to declare it first. So it's going to be char contents equal, then G size length equals 0. And this is the successful case. The loading contents operation succeeded. We have the data. But there could be an error. For instance, we selected a file, but we don't have access to it. Or some other error popped up. Like we are trying to load that file from a remote resource and the connection drops while we are in the middle. In which case, we need an error. And in order to do that, we have the G error here. Let's also use this mg auto pointer. These are ways to avoid having to free manually the string here and the G error if it's set. So it makes writing C slightly more convenient. It's not strictly speaking necessary, but honestly, I started writing code using the auto pointer macros a while ago, and if I'm writing code that I know will not be ported to Windows, or even if it's ported to Windows, it will not be compiled with the Microsoft Visual C compiler, then I will use auto pointers all the time because it's a lot easier. So, how do we distinguish a success from an error? Well, in case of error, the error variable will be set. Right now we pass it as null, but if there is an error, it will be something that is not null. So if error not null, right now we don't want to open up an entire new dialog, so we just print on the terminal that we were unable to open the file. And then we are just going to say error message and return. Printer is a simple function provided by glib that prints the message, a formatted message, to the standard error. And what we want to print out is the error, the message stored inside the error structure. And then we return immediately because we can open the file. Since we're using gAutoPointer, as soon as we go out of scope, the GR will be freed automatically by, I was going to say by the compiler. The compiler will call the function that will be free, that will free the GR. This is in essence what gAutoPointer is. Yes, it's very powerful. It's actually one of the greatest additions to the API in glib, especially if you are writing code that is going to be used only by, compiled only by GCC or CLang. So if you're targeting GNOME, I absolutely 100% encourage you to use gAutoPointer to simplify your C code and make it a lot easier to understand and to keep it in your head. So now we need to take the contents of the file and put it inside the text view. How we do that? Well, we are not going to put them directly into the text view. GTK text view doesn't store the text. It's just a way to display the text. What stores the text is this ancillary object called GTK text buffer. So we go back to our API reference. So every GTK text view widget has a buffer, a GTK text buffer. So we call it here. And then self main next. And what a GTK text buffer is essentially a container of the actual text that we want to display. It's an efficient way of storing text. I'm not going to go into the details of how the text is stored or how it works, but it's fairly efficient. As long as you have reasonably sized lines. So if your entire text file is a single line, you're going to suffer. So this is useful mostly for plain text files that you know have line breaks, like hard-coded line breaks, and you're not trying to use something else, some viewer to add the line breaks for you when displaying it. So GTK text buffer is here. Now we want to set the text inside it. And the simplest way to do it is calling GTK text buffer set text. That conveniently takes text and length. So buffer contents. Yeah. And this one will update the GTK text view automatically, because the text view is a view to the text buffer, which is the model. So if you know about model view controllers, you will see how that works. There is a subtle bug, spoiler alert, there is a subtle issue in this code that we're going to explore in just a second. But for now, we have an error here. Oh yeah, I completely forgot that we are using GIO, which means that we are going to have to use GIO. And then, oh yeah, no, that is not strictly speaking necessary, but yeah, it's a little bit better. Self-undeclared. Oh yeah, because I am dumb. Next, viewer window equals. Okay. And there you go. So let's open the file. Here the to-do. And here we are. It loaded the contents of the file and displayed them inside the text view. So this is great, right? It's done. We can also change them, but we cannot save them. So for the time being, doesn't matter, but there it is. Now, as I said, in the spoiler alert section, there is a subtle bug here. gfile load contents finish, or the loading content operation, loads the exact content of the file, which means that the file can be in any encoding, can have any content whatsoever, as long as it can be represented by C chars, so character binary, anything that is 8 bits per character is absolutely fine. But GTK only understands UTF-8, which means ASCII and the UTF-8 encoding, which is not definitely compatible with any random binary blob. So right now it works fine for us, because the text file that I wrote it with another application that uses UTF-8 to store the data. So GNOME text editor or any other like command line text editor like Vim. But GTK text view get buffer will require absolutely Unicode in UTF-8 format. So we cannot just pass the contents and the length there. So we need to convert the contents to Unicode, to UTF-8. Yes, we can validate the content and pass them. So in theory, we just need to do something like this. Go back here. We can use UTF-8 validate. In this case, validate len. Let's use validate. So we can use GUTF-8 validate and basically assume that we are loading UTF-8. And if we fail the validation, then we don't do anything. And we bail out saying, sorry, this is not valid Unicode. Or we could use gconvert. Gconvert is useful in another case. If you know the text encoding, so the code set used to encode the text, then you can tell it to convert from that code set into Unicode. I apologize for the documentation being a little bit crap, but it hasn't been, JLib hasn't been fixed properly to convert stuff. But in this case, we're loading plain text files, and plain text files do not have any encoding whatsoever. So for instance, gedit has this complex API inside the file selection dialog that lets you say, I know that I'm loading ISO 885915 file, text file. Please convert it to Unicode when you're loading it. But that is a fairly complex piece of machinery and also doesn't exactly work with the native file selection dialog unless you go into weird like ways to structure your UI. So for the time being, we are just gonna validate the content. So after we're loading it, we do let's just go back to UTF-8 validate. And no. And we print another error. No, and then we return. And again, it's safe to return here because we told it to use gauto-free for the contents, which means that the contents char array will be freed when it goes out of scope. And here we go. We can also remove the boolean here because it's kind of pointless. We know we're passing the valid arguments, so we don't need to do the boolean dance. So again, we open it. We open the file. And there we are. So as you may see here, the line goes a little bit here. So what we get here is a scroll bar it's also possible to tell GTK text view to basically break this line when the window gets resized. It entirely depends on what you want to do. But yeah, this is how you write a simple text viewer. Okay. Now we have the text viewer here, but one of the things that we might want to do is show the file path that we just loaded. So we know what we just did. And one way to do this is to have either the file name replaced, either have the file name replace the title of the window, or have a subtitle like we do in other applications. For instance, text editor, yeah, will tell you that it will replace the title with the base name of the file, and it will have a subtitle with the path of the file. And yeah, doing a little bit of cheeky path transformation because it will try to undo the sandboxing, so it knows the original path. But we can do the same. So if we got here, it means that the file was loaded successfully. At this point, we can also take the G file that we have here. Let's assign an intermediate variable there. Then we can do something like this. Base name. And then do this. We can do window set title. Okay. And there you go. Now the title of the window will be the base name of the file. So I think this is a pretty simple demonstration of how to start writing an application with GTK and libadwaita in GNOME using GNOME Builder. Again, it's very simple. There are a couple of complex topics hidden in there. One of them is the fact that the text view has an entirely separate ancillary object there, and there are things like regions of the text, or being able to do syntax highlighting, or other like being able to select and extract the selection, and other things like that. But for a simple text viewer, this is pretty much the basic version of how to write a text viewer application with GTK. There's the asynchronous handling of operations. That is another interesting topic, and it's kind of complex because it opens up an entire class of operations that are performed into separate domains, as opposed to a very simple application control flow. But yeah, this is kind of the basic. Have you thought of uploading these recordings later to YouTube? I always upload the VOD of every session to YouTube the day after I do a stream. So if you wait until tomorrow, you will see this video up on my YouTube channel. But I also want to try my hand into something a little bit different. So I will try to take this video and edit it a little bit to remove some of the dead space and some of my ramblings, so I can compress it a little bit, and instead of being 2 hours and nearly 10 minutes, it's going to take a little bit less, but it's going to be up. My YouTube channel is, I can give it in chat pretty much instantaneously. I think it should be able to be printed out. Yeah, I'll upload the VOD definitely, and the edited version, it depends, because I'm not gonna say I'm not a YouTuber, so I have no idea how to edit a file. I edit a video. I do know how to edit videos, but I've never done it for a video of this complexity, so it will take me a little bit to figure it out. But you can expect it pretty quickly. I'm not going to be it's not going to take a long time. But yeah, the VOD will definitely be up tomorrow, like every other VOD that I have, every other stream that I've done, except the very first, because I completely forgot that the default in Twitch is to not upload the videos, not even in private mode. So that was on me. But starting from the second VOD, second stream, they're all up on my YouTube channel. Okay, so I think for now we can stop here, but I have other plans for this example. Let me just go back to my big head. So I also want to start to this one is just the beginning. I want to also go and add more functionality to this application. For instance, one of the things, I don't want to overload this, like front load it with a lot of stuff, but on Friday, so the day after tomorrow, I am going to add more functionality to this text viewer using more API from libadwaita. For instance, right now you will see that the application loads the file pretty much instantaneously because it's a small file. But one thing that you might want to do is, when the file is loaded and displayed into the how's it called, the main text view area, you will get a toast notification saying file loaded successfully. We can also use that for errors. For instance, there was an error, you will get a pop-up notification to tell you that there was an error and we couldn't load the file. That requires a little bit, again, spoiler, that requires a little bit of rejigging the UI, but it's a feature that we really want for new GNOME applications. So it will be good to have it in a video and show how it works. Another thing that I want to do is adding the way to save changes to the text file. So we will have another we will have another way of another button or another UI element that allows us to save the contents of the file. So if we modify it, then we probably want to add a bunch of other functionality here and there to make it look a little bit better, to make the application look a little bit better. Like, for instance, the preferences dialog. So you can change, for instance, the font type of the text area, or I don't know, the font size, or not only the font type, or use the default from the theme. Again, it's perfectly fine. There are other things like adding more functionality in terms of like niceties there. For instance, the position of the cursor, the line and the column of the cursor. Another thing is searching, popping up a search entry to let you search within the text. That's another thing. Again, I didn't want to front load this, otherwise I could have gone for like 3 hours instead of 2 and change, and it would be a massive amount of information just dumped into your head. And I've done this in other contexts and it's not great, especially without a pause in the middle. It's literally just complete information overload. Smoke coming out of your ears and stuff like that. It's not great. But yeah, for the beginning, like, topic, for the beginning, the first iteration of this getting started like document, I think it's a good start, and this is a good place to stop. But yeah, so if you are watching this on YouTube, then thank you for watching the VOD. I usually do this on Monday, Wednesday, and Friday on Twitch. So if you want to follow me on Twitch to see this live, see me streaming live, then great. Otherwise, on Tuesday, Thursday, and Saturday, I upload the VOD. And you can subscribe to my YouTube channel. If you're watching this again on YouTube, please leave a comment, please press the like button and subscribe to my channel to basically see me make more of this content. Otherwise, I think it's time for me to say thank you for watching and thank you for following along. Have a great rest of the day, and I shall see you all on Friday. Bye.